As we continue talking about nuclear chemistry, we need to review nuclear notation so that when we get into balancing chemical equations and or nuclear equations and talking about um, different types of radiation, you understand the information being presented. So our learning objective is to describe the characteristics of alpha, beta, gamma radioactive decay process in terms of balanced nuclear equations. And it's this nuclear equation part that we're going to focus on. And in nuclear equations, we use nuclear notation. So standard nuclear notation shows a lot more information than just normal atomic symbol notation. It's going to show the chemical symbol, the mass number, and the atomic number. So in normal notation, we would just write carbon with a C. But since we want to know more about its nucleus in nuclear notation, we're going to write it with additional information that shows not only that carbon symbol is C, but how many protons it has and how many neutrons it has. Typically, we also have a different naming convention because atoms have different isotopes. We'll attach a number to the back of the name that represents the mass number, or how many protons and neutrons there are in an atom. And we'll get into this again a little bit later on. So here is a breakdown of nuclear notation. It contains the chemical symbol, which here I'm going to write as an X. It's going to contain the number of protons, or the atomic number, which we write with a Z, and then the mass number, or how many protons and neutrons there are, which we write with an A. And we're going to break these down one at a time. So starting off, the chemical symbol should be the easiest part because this is just the symbol from the periodic table. So if I'm going to try to build a nuclear notation for something like carbon, for example, what would be the chemical symbol for an atom of carbon-13? This, I'm only going to focus on that fact that it's carbon. And so since I know it's carbon, I can go to my periodic table, I can look at carbon, and I see the symbol for carbon is C. So I'm just going to go ahead and write that part in. And that's it for chemical symbol. That's the easiest part of nuclear notation because it's the same. Now, if I want to get the atomic number is actually the number of protons in the atom, and this can also be found on the periodic table. So going back to that problem, what would be the atomic number for an atom of carbon-13? On the periodic table, I'm still going to look for carbon. So I'm going to go find carbon. And typically, the atomic numbers are the whole numbers that are given on the top of the periodic table. So here we have carbon. It has an atomic number of 6. It has 6 protons. So I'm going to go in and I'm going to write that is now a 6. And then finally, we have the mass number. The mass number at the top represents the number of protons and neutrons in an atom's nucleus. And this cannot be found on the periodic table. To do this, you're going to be given the mass number in the name or some other information like the number of neutrons and maybe the element. In this case, what would be the mass number for an atom of carbon-13? Since I'm giving you the isotope name of carbon-13, I'm just going to focus on that 13, and that's the mass number. And I'm just going to write that in. And so here we've built the complete nuclear notation symbology for carbon-13, and we have finished it. Now, in summary, nuclear notation just gives me more information than regular atomic symbols. It's going to include the mass number and the atomic number, which is going to help me get a picture of how many neutrons are inside that nucleus. And that's the last thing you got to be able to do, is just calculate the number of neutrons. And so the number of neutrons is just always going to be whatever my mass number is, A, minus whatever the number of protons is, or the atomic number, Z. So we have A minus Z will give me the number of neutrons. So I can try a quick problem. How many neutrons would the following atom have? Now it's a boron atom. This tells me that it has 5 protons, and it has a mass number of 11. The number of neutrons is equal to the mass number minus the atomic number. In this case, that's 11 minus 5. So this particular atom would have a nucleus with 6 neutrons.